why your cells feel tired after 40, and what to eat. You used to be able to push through. Late nights, early mornings, back-to-back days with no real recovery, and you were fine. Then something changed. Not overnight. It was like a slow dimming. You started needing more sleep to feel the same. Coffee stopped working the way it used to. Your body felt heavier in the afternoon for no obvious reason. Most people blame stress, or age, or just life. But researchers have been building a different case. It is a molecule most people have never heard of. It's called NAD+, nicotinamide adenine dinucleotide. And by the time most people reach their mid-40s, they have roughly half the NAD+ they had in their 20s. Half. That is not a minor fluctuation. That is a fundamental shift in how your cells produce energy. And the downstream effects touch everything. Your metabolism, your sleep quality, your muscle recovery, your cognitive clarity, and your body's ability to repair its own DNA. Today, we are going to walk through exactly what NAD+ does inside your cells, why it collapses with age, how that collapse impacts you, and most importantly, what you can eat and do to start rebuilding NAD+. No supplements required, but we will talk about those too. Let's start at the cellular level. Every cell in your body is running a factory. It takes in raw materials, converts them into energy, and exports that energy in a form your body can use. That form is called ATP, adenosine triphosphate. Think of ATP as the currency your body spends on every physical and cognitive task you perform. The factory does not run on its own. It needs workers. And one of the most important workers in this entire operation is NAD+. Here is what NAD+ does. Inside your mitochondria, your cells are breaking down glucose and fat through a process called cellular respiration. During this process, NAD+ acts as an electron carrier. It picks up electrons during the breakdown of nutrients, becomes NADH, and then delivers those electrons to the electron transport chain, where the ATP is generated. Without NAD+, this chain stalls. The factory slows down. Your cells cannot produce energy efficiently, and every system that depends on that energy starts to lag. Energy production is only part of the story. NAD+ also fuels a separate class of proteins called sirtuins. Sirtuins are sometimes called longevity proteins. They regulate inflammation, manage oxidative stress, and control epigenetic changes, how your genes are expressed as you age. There are 7 sirtuins in the human body. All of them depend on NAD+ to function. A third major role of NAD+ is the primary substrate for PARP enzymes, which are your cell's DNA repair crew. Every time your DNA takes damage from UV radiation, toxins, or simple metabolic byproducts, PARP enzymes use NAD+ to patch the break. If there is a lot of damage, a lot of NAD+ is consumed. Over a lifetime, this repair demand accumulates, and it is one of the reasons NAD+ levels fall so steeply as we get older. So to summarize the mechanism, NAD+ is a multi-purpose molecule. It is a cellular multitasker, powering energy production, activating longevity proteins, and enabling DNA repair. When it is abundant, your cells are running a tight, efficient operation. When it is depleted, the whole system starts cutting corners. And after 40, depletion is the default. When NAD+ levels fall, the consequences do not announce themselves dramatically. They arrive as things that are easy to explain away. You are a little more tired than you used to be. Your workout recovery takes longer. You feel mentally slower in the afternoon. Your sleep is technically fine, but you wake up feeling like it was not quite enough. These are not random misfortunes. They are the predictable downstream effects of mitochondrial inefficiency. Let's be specific about what the research shows. Muscle fatigue and weakness. When NAD+ drops, mitochondria and muscle cells produce less ATP. The result is earlier fatigue during exercise and slower post-exercise recovery. A 2016 study published in Cell Metabolism found that restoring NAD+ levels in aged mice dramatically improved muscle function and endurance, essentially reversing aspects of age-related decline. Cognitive fog. The brain is one of the most metabolically demanding organs in the body. Neurons require enormous amounts of ATP to maintain their electrical activity. When NAD+ falls and mitochondrial output drops, cognitive sharpness goes with it. The brain compensates for a while. But sustained NAD+ deficiency is associated with increased neuroinflammation and impaired neuroprotection. Metabolic dysfunction. NAD+ is required for proper insulin signaling and glucose metabolism. Low NAD+ is directly associated with insulin resistance, one of the early markers of metabolic syndrome. Sirtuins, like SIRT1, which help regulate fat storage and blood sugar, are reduced when NAD+ is low. The result is a gradual shift toward less efficient fat burning and more inflammatory fat storage. Accelerated cellular aging. This one matters long-term. When NAD+ is low, PARP enzymes cannot repair DNA efficiently. Damage accumulates. Telomeres shorten faster. Senescent cells, what researchers call zombie cells, accumulate in tissues and drive systemic inflammation. This is not hypothetical. It is one of the central mechanisms in the biology of aging. You can change this trajectory. NAD+ levels are responsive. Diet, lifestyle, and targeted nutrition can shift them meaningfully, and the research on this has advanced significantly in the past decade. Let's talk about what you can do. Your body can produce NAD+ through several biological pathways. The most efficient of these in adult humans is called the salvage pathway, and it runs primarily on a precursor molecule called NMN, nicotinamide mononucleotide, or its close relative NR, nicotinamide riboside. Both of these compounds are present in food. Both can be converted into NAD+ inside your cells. Food sources of NMN and NAD+ precursors. Edamame is one of the richest whole food sources of NMN available. A standard serving of around 150 grams provides a meaningful dose of this precursor in a form your body can absorb efficiently. Avocado is another high NMN food that also provides healthy fats to support cellular membrane integrity. This matters because your mitochondria are enclosed in membranes, and membrane quality affects mitochondrial function. Broccoli, cabbage, and other cruciferous vegetables contain NMN alongside sulforaphane, a compound that activates the NRF2 pathway and provides additional antioxidant protection to mitochondria. Think of these as doing double duty. Mushrooms, particularly shiitake and cremini, are rich in niacin, which is another NAD+ precursor through a separate pathway called the Price-Handler pathway. They are also one of the few plant-based sources of ergothioneine, an antioxidant that concentrates in mitochondria and provides direct protection. Fish, particularly salmon, tuna, and sardines, are excellent sources of niacin and also provide omega-3 fatty acids that reduce mitochondrial inflammation. Chronic low-grade inflammation is one of the key drivers of NAD+ depletion, so anything that reduces that inflammatory burden helps preserve what you have. Beyond food, there are 3 lifestyle levers that have the strongest evidence base for raising NAD+ levels. Number 1. Exercise, specifically high-intensity intervals. Exercise activates AMPK, an energy-sensing enzyme that upregulates the NAD+ biosynthesis pathway. High-intensity interval training in particular has been shown to increase NMN production and SIRT, one activity more efficiently than steady-state cardio. Even 2 to 3 short HIIT sessions per week produce a measurable effect. Number 2. Time-restricted eating. Fasting and caloric restriction activate sirtuins and reduce NAD plus consumption by lowering the inflammatory burden on PARP enzymes. You do not need to fast aggressively. A consistent 14 to 16-hour overnight eating window is enough to trigger these pathways and allow your NAD plus reserves to partially recover. Number 3. Reducing alcohol and processed sugar. Both of these compounds consume NAD plus directly. Alcohol metabolism in the liver is heavily NAD plus dependent, and chronic alcohol use is one of the fastest ways to deplete systemic NAD plus levels. Fructose, particularly in liquid form, similarly drives NAD plus consumption through inflammatory metabolic byproducts. Reducing both frees up NAD plus for the functions that matter. A note on supplements: NMN and NR supplements have generated significant research interest in the past 5 years. Human trials have shown that both can raise NAD plus levels in blood and tissues, sometimes substantially. They are not necessary if your dietary and lifestyle foundations are strong. But for people over 50 who want a more direct intervention, they represent one of the more evidence-backed options in the longevity supplement space. If you are considering them, look for NMN in the 250 to 500 milligram range, taken in the morning with food. Consult your physician if you are on medications, particularly blood thinners or diabetes medications. Everything we just talked about in one bowl. Every element in this bowl is doing something. The salmon gives you niacin and omega-3s to reduce mitochondrial inflammation. The edamame and avocado provide NMN directly. The mushrooms contribute niacin and ergothioneine. The broccoli adds sulforaphane for cellular protection. The ginger reduces inflammatory signaling. And the brown rice provides the B vitamin cofactors your body needs to run the NAD plus biosynthesis pathway efficiently. This is not a trend bowl. It is a mechanistically designed meal. Eat it 2 to 3 times a week, and you are doing more for your cellular energy than most people do in a month of supplements. NAD plus decline after 40 is real. The research is clear, the mechanism is well documented, and the consequences are ones most people are already living with without knowing why. But this is one of the few areas of aging biology where your everyday choices have a documented impact. What you eat, when you eat, how you move, and what you avoid. These are the inputs your cells use to decide how much energy they have to give you. Start with the bowl. Work on the sleep window. Add the exercise interval sessions.